This is lesson 6.39, Ratios in Similar Solids. Your objectives are to take similar solids, use a ratio, and find a volume, surface area, or length of one or the other of them using that ratio and the change in dimensions conversion. Two similar cones have a scale factor of 3 to 5. If the volume of the larger cone is 900 centimeters cubed, find the volume of the smaller cone. Well, their scale factor is 3 to 5. That's one dimension. The volume of the large cone is 900. 3 over 5, 5 is larger, which means large needs to go in the denominator of the second fraction. We're looking for the smaller volume. Since scale factor is one dimension and volume is 3 dimensions, we need to cube the scale factor in order to make the dimensions match. So what we have is 27 over 125 equals x over 900. Now, just solve the proportion. Cross multiply 125 times x equals 27 times 900. 125 times x is 125x. 27 times 900 is 24,300. Then divide both sides by 125, and x is 194.4 centimeters cubed. So make your proportion, make sure the dimensions match, so apply the correct exponent or root, and then cross multiply to solve the proportion. Two similar spheres have a scale factor of 9 to 10. If the surface area of the smaller sphere is 43 inches squared, find the surface area of the larger sphere. 9 over 10 is small over large. If the small sphere area is 43, then 43 is the numerator. Large will be the denominator. Scale factor is one dimension. Surface area is 2 dimensions. To have one dimension match 2 dimensions, we need to square the one-dimensional ratio. This gives us 81 over 100 equals 43 over x. Now cross multiply and solve. 81 times x equals 100 times 43. 81 times x is 81x. 100 times 43 is 4,300. Divide both sides by 81, and x is approximately 53.1 inches squared. The key step is taking the one-dimensional scale factor and squaring it so that it equals the dimensions of the two-dimensional surface area. The ratio of the volumes of two similar prisms is 343 to 8. If the height of the larger prism is 14 feet, find the height of the smaller prism. 343 over 8 is large over small, so the large height will be in the numerator. The small height will be in the denominator. Volume is 3 dimensions. Height is 1 dimension. To make 3 dimensions match 1 dimension, we will take the cubed root of the 3-dimension ratio. The cubed root of 343 is 7, and the cubed root of 8 is 2. Now, The dimensions match, and we can solve the proportion. Cross multiply. 7 times x equals 2 times 14. 7 times x is 7x. 2 times 14 is 28. Divide both sides by 7, and x is 4 feet. So the three-dimensional ratio of volume needed to have the cube root applied so that it would match the one-dimensional ratio of height. The scale factor of two similar pyramids is 2 to 5. If the slant height of the larger pyramid is 60 millimeters, find the slant height of the smaller pyramid. 2 over 5 is small over large, so the large pyramid height would go in the denominator. Small will be the numerator. Scale factor is one dimension. Slant height is also one dimension. There is no dimension change here, so we will solve this as it is already. 2 times 60 equals 5 times x. 2 times 60 is 120. 5 times x is 5x. Divide both sides by 5, and x is equal to 24 millimeters. There was no need to apply an exponent or a root because both fractions in the ratio or in the proportion were one dimension, so they were already the same. The ratio of the areas of two similar rectangles is 81 to 16. If the base of the smaller rectangle is 24 centimeters, find the base of the larger rectangle. 81 over 16 is large over small, so the small base length will go in the denominator. The large base length is the numerator. Area is 2 dimensions. Base length is 1 dimension. We will square root the 2-dimension area so that it will match the 1-dimension base length. The square root of 81 is 9, and the square root of 16 is 4. Now cross multiply and solve. 4 times x equals 9 times 24. 4 times x is 4x. 9 times 24 is 216. Divide both sides by 4, and x is 54 centimeters. So the 2-dimension area ratio became a match to the 1-dimension base length ratio by square rooting it. The ratio of the volumes of two similar cylinders is 8 to 27. If the surface area of the smaller cylinder is 120 inches squared, find the surface area of the larger cylinder. 8 over 27 is small over large. So the smaller cylinder surface area will be the numerator. Large will be the denominator. Volume is 3 dimensions. Surface area is 2 dimensions. To have 3 dimensions be equivalent to 2, we need to cube root the number and then square it. Cube root the number and then square it. The cubed root of 8 is 2. 2 squared is 4. The cubed root of 27 is 3. 3 squared is 9. Now, each fraction represents a 2-dimensional ratio, and we can cross multiply and solve. 4 times x is 4x equals 9 times 120. 4x equals 1,080. Divide both sides by 4, and x is 270 inches squared. So a three-dimensional ratio became a match to a two-dimensional ratio by taking the cubed root and then squaring it. So organize your proportions. Make sure that small is in the same fraction place as small and large is in the same place as large. Then apply the correct exponent or root to make the ratios match.